Hello, Algebra 1 students. This is Mrs. Youd. Today I'm going to teach you Chapter 7, Lesson 8, which is about factoring polynomials completely. So you've learned all of the rules about factoring, all of the tips and the tricks. There's only one more little tip that we need to share, and that is that sometimes you can factor more than once, and sometimes you can do something called group factoring, which we'll be going over today as well. Please have your journals open to page 241. Factoring by grouping is when you have four terms in your polynomial, which we haven't really seen too much yet. You might be able to do something called group factoring, which we'll go over in some more detail down here. And factoring completely. After doing one type of factoring, you need to start double checking what you have left. You might be able to continue factoring again so that you'll be able to even break it down further into more factors. Let's talk really quickly about factoring by grouping. So if you have four terms in your polynomial, sometimes what you can do is group the terms into pairs. What you're going to do is you're going to factor out the GCF of each of the pairs, and then you look for the factor that is similar, and you can factor out the common binomial. This is a process called factoring by grouping. Let's do a couple of examples of that in this notes section. So here I have a polynomial that has 1, 2, 3, 4 terms. So what I'm going to do is I'm going to see if I can group factor. I'm going to split it up into two parts. So there we have our first set and our second set. And I'm going to see, is there something that I can factor out of this first set? What is the GCF that we can factor out there? So I notice that I can factor out an x squared out of this first set. So that leaves me with x squared here. And then on the inside, what I have left is x plus 3. Now I'm going to see if I can factor out something out of the second set. I notice that I can factor out a 2. Now we still have a plus in here, so that's important. I need to continue having that. I'm factoring out a 2. Sorry, that should have been a plus. And what I have left is x plus 3. Now you'll notice that we have x plus 3 written twice. So that means that we can factor out an x plus 3 out of this. So basically we're dividing out an x plus 3 and dividing out an x plus 3. And so that means that my answer, one of my factors will be x plus 3, and my other factor will be what's left, which is x squared plus 2. So x squared plus 2. Now what I would do is I would double check that, see if this could be continuing to factor, and this one cannot continue to factor. So that means that this is as good as it gets for that factor, that group factor. Let's do another example. So here I have another polynomial that has 1, 2, 3, 4 terms. However, I notice that if I were to group this, there's nothing that I can factor out. There is something I could factor out here, but just to double check and see, so the way it looks right now is that I cannot group factor, but what I could do is flip those two middle terms. So I could change this to x squared plus x plus y. So all I did was flip-flop these two middle terms here, and then plus xy. Now, if I look at it, I actually can group factor because there is something to take out of each of the pairs. Out of the first pair, I can take out an x, so that leaves me with x, and then I'm left with inside x plus 1. And over on the other pair, I can take out a y, and so I have plus y, and then notice I have 1 plus x. So you'll notice that they don't really look the same, x plus 1 and 1 plus x. However, hopefully you can tell that these are actually the same, because x plus 1 is the same as 1 plus x, because addition is commutative. You can flip it around, right? So that means that we can group factor this. One of our groups is going to be x plus 1, and then the other one is what's left, which is x plus y. So we have x plus y. Now, if you're doing group factoring and you're not comfortable with it, of course, you can always go back to double checking and seeing if your answer is correct. So let's do that really quick. So x times x is x squared, x times y is xy, and then we have 1 times x is x, and 1 times y is y. And I know that that's not in the same order that we have it up here, but if you look at it, all four of the terms are the same. So it does actually check out. So when you're factoring completely, there are 4 steps for you to look for. Step number 1 is you want to factor out the greatest common factor. So if possible, you want to factor out the GCF. And you'll notice this example over here is doing just that. So they have 3x squared plus 6x, and they were able to factor out a 3x. The second thing that you're going to be looking for is you're going to look for a difference of 2 squares or a perfect square trinomial. However, if you want to skip this step, you can, because remember, this is the one that if you want to look for the patterns and the tricks like you learned in 7.7. So this step can actually be skipped if you would like to. Step number 3 is to factor the trinomial ax squared plus plus bx plus c into your 2 parts. And this is basically just factoring like normal. And the last step is if you have 4 terms, then you want to try that factor by grouping that we just learned about before. I'm going to add one more step here, and that is to check to make sure that you're done factoring, because sometimes there might be more that you can do. You might be able to factor again. These first 4 problems are using the factoring by grouping, so we're just going to be practicing that. So let's take a look at number 2. So I notice that I do have 4 terms, so I'm going to see if I can factor by grouping. And I notice that on the first set, I can take out an A, and on the second set, I can take out a B. So that means that if I take out an A, on the first set, I'm left with C plus D. And if I take out a B on the second one, I'm left with C plus D. So you'll notice that we do have 2 that are exactly the same, C plus D. So that means that my answer is going to be C plus D. And then my other group is going to be A plus B because that's what's left over. And so there we have the answer there. Let's take a look at number 3. So I notice D squared plus 2C cannot be factored. There's not a GCF there. So what I'm going to do first is I'm going to flip the 2 middle terms around and see if I can group factor after I do that. So D squared, and then this is CD, and then 2c plus 2d. All right, so now let's see if we can group factor here. So I notice I can take out a d on the first set, and I can take out a 2 on the second set. So that leaves me with d, and then what's left over is d plus c, and then I can take out a 2, and what's left over is c plus d. So you'll notice that we have D plus C here and C plus D here. And hopefully you could see that those are exactly the same. They're just flipped around, and remember addition is commutative, so that's allowed. So then one of my groups is C plus D, one of my factors, and my other factor is going to be what's left over, which is D plus 2. So we have D plus 2. I want to help you get started on number 1. So I'm going to do my group factoring here. And I notice I can take out a b squared from the first, but notice that there's nothing nothing to take out on this set. So, but watch what happens when I factor out the b squared. So if I take my b squared out, I'm left with b minus 4. And if you notice, that's exactly the same thing that I have right here. So that means it's kind of like you're factoring out a 1, right? So plus 1 and then b minus 4. And so that means that we can group factor this. One of my factors would be b minus 4, and then the other factor is what's left over, b plus 1. Sorry, b squared plus 1. One thing I wanted to point out to you is that whenever you have a square left, there might be a possibility that you could continue factoring. This cannot be continued factoring. However, I just want to point something out to you. If it was b minus 4, and let's say that instead of b squared plus 1, it was b squared minus 1, well, that can continue to be factored because b squared minus 1 is a difference of two squares. So this actually can be continue. So this would be b minus 4, and then b plus 1, b minus 1. Okay, so you actually, if that's what I mean when I say continue checking to see if you can keep factoring. In this case, it was not minus, it was actually a plus, so there was nothing more you could do. But if it was a minus, then there would be more that you could factor. Go ahead and try number 4 on your own. All right, go ahead and check your answer and see how you did. If you made any mistakes, see if you can find them. Let's take a look at number 5. We're going to group factor again. So we're going to take out the numbers. So let's see what we can take out of the first group. Looks like I can take out an s. So that means we have s, and then we have 8s squared plus 1. Now, when I take out, you'll notice when I take out an 8 out of the next one, so if I take out an 8, then it's going to end up being 8s squared, but it'll be minus 1. I don't want it to be minus 1. I want it to be a plus 1. Now, whenever you have a minus here, that's a little trick to you that you actually want to take out a negative number instead. So I'm going to take out a negative 8 instead, and when I do that, I get 8s squared, and then it changes to plus 1. Now, if you double check that, negative 8 multiplied by 8s squared is in fact negative 64s squared. Negative 8 times 1 is negative 8. So again, whenever you have a negative here, you're going to want to take out a negative, and that will help you to group factor. So now we have the exact same binomial factor here. So that would be one of my binomial factors is 8s squared plus 1. And then the other factor that we have is what's left over, which is s minus 8. And there we have our answer. Let's go ahead and take a look at number 6. So again, I'm going to group factor, and I notice out of the first group, I can take out a 2a squared, and that leaves me with, so I have 2a squared, and that leaves me with 6a plus 1. And I notice again that there is a negative there, so I'm going to need to take out a negative number. And what I can take out then would be a negative 5. And so that leaves me with 6a plus 1. The nice thing about group factoring is that I know whatever I get on my first binomial, I know has to be the same over here in order for me to be able to group factor. So that helps me decide what I need to divide out. That's something to help you think about it. So one of my binomial factors is 6a plus 1, and the one that's left over is 2a squared minus 5. I would like for you to go ahead and try numbers 7 and 8 on your own. All right, go ahead and check your answers and see how you did. If you made any mistakes, see if you can find them. For these next set problems, we need to factor completely. So that's a big hint to you that there might be more that you have to do when you work through the different steps. So let's take a look at number 9. I notice that I have 4c to the third minus 4c. So the first thing I notice is that I actually can do the first step, which is to factor out a GCF. So 4c can be taken out, and that leaves me with 4c is on the outside, and then I have c squared minus 1 on the inside. I notice that I can continue factoring this second because that's the difference of 2 squared. So that would be c times c, and positive 1 and negative 1. So then that means that my final answer would be 4c, and then I have c plus 1 and c minus 1. And so that now is factored completely. Remember that anytime you have a square, that's a hint to you that you might be able to continue going. Let's go ahead and take a look at number 10. So on number 10, I can take out something first. I notice I can take out a 25x squared. And when I do that, I'm left with 25x squared on the outside. And on the inside, I have 4x squared minus 1. This is also a difference of 2 squared because that's a perfect square and that's a perfect square as well. So I can continue because this is going to be 2x and 2x and positive 1 and negative 1. And that if you cross product, you end up getting 0, and notice there's nothing in between there. So it means my final answer in here is going to be 25x squared. And then I have 2x plus 1 and 2x minus 1. And that's going to be my answer for number 10. Let's take a look at number 12. So on number 12, I do have a perfect square here, but this one's not a perfect square. So I know that it's not that special pattern. Okay, so let's go ahead and try some things. Let's try 3x and 3x, and let's go ahead and try 7 and negative 2. So when I cross product, I get negative 6x, and I get positive 21x. Nope, that doesn't work. So let's try something else. So I erased it and I flipped it around. So now this time I have negative 21x and I have positive 6x. You know what? That's going to be the same thing, so that doesn't work either. Okay, so I need to erase and retry. All right, now I'm trying 14 and 1, and I notice that it still doesn't work. Oh my goodness, this one's not easy, is it? Okay, so I'm pretty confident that 3x and 3x is not the answer. All right, let's go ahead and try something different then. I think the only choice now is 9x and x. So let's go back to 7 and 2 and see if that works. One of them needs to be negative, so that'll be negative 18x and 7x. Whoops, that doesn't work either. I can keep going, but I'm not going to because I've actually worked through this problem before and I know that nothing works. This is a tricky question because it's actually unfactorable. So the answer is not factorable. Fortunately, that doesn't happen very often in these kind of problems. Let's take a look at number 13. So on number 13, I notice that I can take out a 2. I can factor out a GCF of 2. So that's going to give me 2, and then I have 10p squared plus 11p minus 6. All right, let's see if we can continue factoring this part. So if I look at it, I can do 5p and 2p. And then on the other one, I can do, I have to have one of them be negative. So negative 2 and 3, I'll try that. And let's cross a product there. So 5 times 3, so it'd be 15. And then we have negative 4. And I notice that that does indeed add up to the middle. So that's good. So that means my answer, don't forget your 2. So we have 5p minus 2, and you have 2p plus 3 as your final answer there. Numbers, I just want to point out, numbers 15 and 16 are actually very similar to what we did on the previous page. So I'm going to have you not bother doing those because I don't want you to repeat some extra things. I'd like you to go ahead and try numbers 11 and 14 on your own. All right, go ahead and check your answers and see how you did. If you made any mistakes, see if you can find them. These next set of problems want us to actually solve the equation. And remember, we do that whenever we need to graph the quadratic equations. It helps us to find the zeros. So that's what we're practicing here. So let's take a look at number 17. I notice the first thing I can do is factor out a 3. So I'm going to do that first, and I'm left with x squared minus 7x plus 10. Now I look and see, and I can continue factoring what's inside there. So I have x times x, and the 10 is going to be negative 5 and negative 2. I notice I made them both negative because the center term was negative. Now if we cross multiply that, we have negative 2x, and we have negative 5x, which does indeed equal the middle term, negative 7x. All right, so then we have 3 and x minus 5 in one factor, and then x minus 2 in another equals 0. So notice that when we need to solve for zero, remember we need to use the zero product property. Well, 3 equaling 0 makes no sense at all, so you can actually ignore that out there. You would not be able to ignore it if it had um, an x there. So if there's an x here, then you would have to use it. But since there's not an x, there's nothing really we need to do. The next factor is x minus 5 equals 0. And then lastly, we have x minus 2 is equal to 0. When we solve for x on both of those second two factors, we have x is equal to positive 5 or x is equal to positive 2. And so that would be my answer on number 17. Let's take a look at number 19. The first thing I can do is take out a c squared. And when I do that, I have c squared, and I'm left with c squared minus 81 is equal to 0. So I can continue to factor this because this is c times c and negative 9 times positive 9. So my next step would be c squared, and then I have c minus 9, and I have c plus 9 is equal to 0. This time, what I have out here does make a difference because you'll notice that if I do c squared equals 0, that does indeed work. I can see is going to equal 0 for that one. So this one is c minus 9 is equal to 0. And lastly, I have c plus 9 is equal to 0. So when I solve for all of those, I get c is equal to 0. Or now this is going to be a positive 9. This one's going to be a negative 9. So I'm going to shorthand it and just write plus or minus 9. And that is my answer for number 19. Let's take a look at number 22. The first thing I'm going to do on 22 is move these two pieces to the other side. And so when I do that, I get x to the third plus 3x squared minus 16x minus 48 is equal to 0. Now, there's nothing that I can pull out as a GCF on all four terms, but since there are four terms, I'm going to see if I can factor by grouping. On the first set, I can take out an x squared, and on the second set, I can take out a negative 16. Notice that I'm taking out a negative because there is a negative here. So my next step then would be x squared, and then what's inside will be x plus 3. And then I have minus 16 x plus 3 equals 0. All right, so now we have x plus 3 is one of our factors, and then x squared minus 16 is another factor. I notice that I still have a square here, so I'm going to double check and see, can I continue factoring? And yes, I can, because this is a difference of two squares. So that's going to be x plus 3. And then this x squared minus 16 becomes x plus 4, and then x minus 4 equals 0. So if I solve this equaling 0, I get negative 3. If I solve these two equaling 0, I get plus or minus 4. And there's my answer. I would like for you to please do 18, 20, and 21 on your own. All right, go ahead and check your answers and see how you did. If you made any mistakes, see if you can find them. All right, everyone, that's it for today. Thanks for watching.